Hello everyone, we are Team 4 and our senior design project was the redesign of specimen retrieval bags and our sponsor was Boston Scientific. The purpose of a specimen retrieval catch bag is to remove a harmful or unwanted tissue during laparoscopic surgery. Specimen retrieval catch bags on the market today lack the ability to be a true one-size-fits-all medical device. Boston Scientific wants to come up with a catch bag that can be used for women for ovarectomy and cystectomy procedures, as the catch bags available today are too big for many of the patients that need them. Figure 1A shows the basic tools necessary for a laparoscopic ovarectomy procedure, and Figure 1B shows a specimen retrieval catch bag that's available today. Our project goal was to redesign specimen retrieval devices to be more anatomically inclusive regardless of size. This would be accomplished by following the 4 constraints of safe, easy to use, flexible, and cost effectiveness.
We began designing our solution by first investigating the current specimen retrieval systems on the market. There are 2 main types of specimen retrieval systems, those that are manually deployed like the EndoBag, and those that are automatically deployed like the EndoCatch and the ReliCatch. We then came up with a simple wire loop design made of nitinol. Pushing on one end of the loop opens and expands the mouth of the bag. Pulling on one end of the loop closes and retracts the opening of the bag. This simple manipulation allows for the bag opening to change size and shape depending on patient-specific parameters. Using computer-aided design software, the team created a mock-up of what a fully assembled version of our device might look like. After several handle design iterations, our final prototype was made of 2 halves that come together around a trigger mechanism and a plunger mechanism. The trigger mechanism is responsible for changing the size and shape of the bag by pulling and pushing on one end of the wire loop. The plunger mechanism pushes and pulls on both ends of the loop, opening and closing the bag.
To measure the ability of our device to account for anatomical diversity, we first quantified bag opening area and roundness. Bag opening roundness is a number from 0 to 1, where 0 is a perfectly straight line and 1 is a rounded circle. To do this, we took images of the different bag opening configurations from our device and a market device. These images were imported into MATLAB, where we could quantify bag opening area and roundness. And you can see here that the largest configuration of our device had a significantly higher bag opening area than the market device. Also, the roundness of all our configurations was improved compared to the market device, which is important because the tissues we are trying to remove are round. Next, we wanted to simulate specimen retrieval with our device. So to achieve this, we made tissue mimics of an ovary and ovarian cysts of different sizes. Here you can see that our device can be inserted into the body cavity. We can deploy it, open the bag, insert the specimen, and close the bag, and take the specimen out of the body cavity. And here is a video with the handle end of the bag in view of us deploying the device and opening up that bag. And here's another video of us retracting the device and the specimen from our fake body cavity.
As discussed previously, the design created by our team has allowed for both an increase in the anatomical adaptability as well as an increase in the area of the catch bag opening. This increase in roundness is better suited for laparoscopic tissue removal, such as that of an ovarian cyst, which you can see circled here in red. In terms of ongoing work, our team would like to incorporate a ratchet system into our handle design. This would work in conjunction with a release button, which would allow for better control over the size of the catch bag opening. As an alternative approach, our team did look into soft robotics. This could increase the manipulation capabilities. However, further exploration would need to be done with this to determine whether or not it would be beneficial. Thank you, everyone.